One of the things that we did in class was look at tables to decide if they were proportional, linear, or nonlinear. And one of the things that we can quickly do is decide, is it proportional or not? And so using our knowledge from grade 7, we know that if it's proportional, if we take our y values and divide them by x, that they would all have to come out to be equal to the same number, which is our k, our constant of proportionality. So if we wanted to check, remember 2, 5 would be an ordered pair, so those two numbers correspond with each other. They are part of the same point. So we would have to do 5 divided by 2. We would have to do 12.5 divided by 5 and 25 divided by 10. And remember, the fraction bar is division, so we are writing these are division problems. 5 divided by 2 is 2.5. 12.5 divided by 5 is 2.5. 25 divided by 10 is also 2.5. So because all of these are equal, that is our k. This table is proportional, which would tell us that it is linear, and it also passes through the origin. Now, this wasn't a part of the question, but if I ask for an equation, remember, if it's proportional, our equations are always in the form y equals kx, and since k is 2.5, then our equation for this table would be y equals 2.5x. Okay? So if we look at example 2, table 2, if my first question is it proportional? Well, if I look at this first point, 0, 5, that answers my question, actually, because to be proportional, you have to be linear, and you have to pass through the origin, and the origin is 0, 0, so this tells us that it doesn't pass through the origin. And if it doesn't pass through the origin, it is not proportional. Okay? Well, if it's not proportional, then it could still be a straight line. It could just be a straight line that doesn't go through the origin, or it could be nonlinear. So the only thing that we know so far is it's not proportional. Now, you could also have confirmed that by looking at y divided by x, like we did on the last problem. That would be 5 divided by 0, 9 divided by 2, and 13 divided by 4. And while we can't do 5 divided by 0 because division by 0 is undefined in our number system, we could do 9 divided by 2, and that is 4.5. We could do 13 divided by 4, that is 3.25. And because these are not equal, that confirms our conclusion that it is not proportional. Just because it's not proportional, again, doesn't mean it's not linear. So now we're going to think about whether it's linear or not. And we've talked about linear relationships. They're a straight line, and they're a straight line because they have that constant rate of change throughout the entire relationship. So one of the things that we looked at in class, and this would be to figure out if it's linear, we started looking at the sentence, as x increases by 1, then y is either going to increase, or it could possibly decrease, depending on our situation, by blank. And we started trying to figure out that piece. And if that was the same, if it increased the same amount every single time, then we could conclude that it was linear. To do that, we actually started just looking at what's going on in the table. So our x value went from 0 to 2, so it actually increased by 2. So actually when we started, we would write a sentence like this, as x increases by 2. Well, then what did y do? Well, y actually from 5 to 9 increased by 4. But again, if we're looking for our unit rate, we want it to be 1. So then we thought about, okay, all of that knowledge from 7th grade with proportional thinking and ratios and scaling them up and down, how could we turn this sentence into as x increases by 1? Well, if we were going to do that, we would have to divide by 2, which means that for the increase of y, we would also have to divide by 2. And if we scale that down if x is only taking half the jump, it's only going up 1 instead of 2, then y would also take half of the jump, so y would increase by 2. So when we do this, if we can make it so that x is increasing by 1, this part of the sentence gives us our unit rate. Y increases by 2, so we would have a unit rate of 2. But that's only for 2 points, right? We need to make sure that that relationship holds throughout the entire table. So here, if I look, x is increasing by 2. And if I look here, from 9 to 13, y is increasing by 4. So that actually gives us the exact same sentence here, which would simplify to the exact same sentence here. So it would give us the same unit rate. So this relationship is actually linear because there's a constant rate of change. Okay? And we're going to get more into the writing the equation part of that. Our unit rate is 2, and we do see where it starts. And so one of the next things that we're going to work on is actually writing the equation for that line. But right now we're just looking for linear, proportional, or nonlinear, and this one is linear. So then if we go to table 3, our first question might be, is it proportional? And if we're going to do that, 3 divided by 4, 6 divided by 5, 13 divided by 7. And at this point, I could stop. I know it's not proportional. I don't even actually have to divide because 3/4 is less than 1. 6/5 is more than 1, so they can't be equal. But if we really wanted to, we could say 3/4 is 0.75. 6/5 would be 6 divided by 5. That is 1.2. They are not equal. It doesn't matter if 13/7 is equal or not. They're not all three the same, so it's not proportional, right? 13/7, by the way, is not equal. If you wanted to show that part, you're going to get a decimal for that. It is approximately 1.86, which is also not equal, all right? It could have been possible that it was equal to one of these, but it takes all of them being equal. So we know it's not proportional. Now the question is it linear? And if it's linear, then we can start to look at, is there a constant rate of change? So here, x is increasing by 1. So as x increases by 1, y increases by, if we look at our y's, it increased by 3. We need to do a little more exploring, right? So what happens here? Well, x increases by 2. And when x increased by 2, y increased by 7. And if we were to take this green sentence from that second set of increases, if we wanted to make this by 1, we would have to divide by 2. So if we divided by 2 here, 7 divided by 2 is 3.5. So our sentence would be, as x increases by 1, y increases by 3.5. And if you look at this sentence and this sentence, you notice they're not the same. As x is increasing by 1, y is increasing by different amounts, which means that there is not a constant rate of change. And if there's not a constant rate of change, then it is non-linear. Okay. And then the last table, if we were to think about those same ideas, is it proportional? 9 divided by 3, 13 divided by 5, 21 divided by 9, 9 divided by 3, is 3. 13 divided by 5 is 2.6, and we can stop right there because we know it is not proportional. So then our question is it linear or nonlinear? And if we look at our sentence, if we try and create our sentence, as x increases, I'm going to abbreviate here, as x increases by 2, y increased by 4. And again, if we were to break that down into a unit rate, we want that to say as x increases by 1, y increases by, and to get from 2 to 1, we would have to divide by 2. So again, we're going to divide by 2 to scale that ratio down, and we would get 2. So as x increases by 1, y increases by 2. We need to explore the rest of the table. So here, from 5 to 9, x is increasing by 4. From 13 to 21, y is increasing by 8. So that sentence would say, as x increases by 4, y increases by 8. And if we were to scale that to 1, we would have to divide by 4. So we're going to divide by 4 for both of those, and we will get the sentence, as x increases by 1, because 4 divided by 4 is 1, then y increases by 8 divided by 4 is 2. So now, if we look at our two sentences, we see that we get the exact same sentence, which means that there is a constant rate of change. And if there is a constant rate of change, then it is indeed linear.